Hi, this is Mr. Knowles, and this video focuses on using groups to represent multiplication. In class, we're going to be learning about different methods and models of multiplication, and there's going to be an emphasis on using visual models or drawing sketches to represent students' thinking. So I really want to encourage you to draw things out, sketch things out to represent what you're thinking. So let's get started. Let's say we have a problem. For example, 3 times 2. And you may know the answer to this already, but I'm going to ask you to build a model of that. So 3 times 2. And one way to solve this is to put them into groups. So you could take some squares or tiles or anything, it doesn't have to necessarily be square, and start putting them into groups. And one way to do that is like this, where I have 2 groups of 3. So I have 2 groups. There's 1, and there's 2. I have 2 groups of 3. 2 groups of 3. We'll even go farther and say 3 tiles. How many total tiles are there? Well, there's 6, right? If I were to count them, 1, 2, 3, 4, 5, 6. I can take that same problem, think of it in a little bit of a different way, and you probably already know what I'm going to do. I can make 3 groups of 2. Like that. So I could have 3 groups, and inside each group there are 2 tiles. So I could have 3 groups of 2 tiles, and that also equals 6 total tiles. Basically what we're doing is a property of mathematics called the commutative property. And this property works in addition and in multiplication. And basically the visual on the right over here is showing us what we were just working on there. So for addition, for example, 4 plus 2, which is equal to 6, is equal to 2 plus 4. In multiplication, which we just did, we learned that 3 times 2 is going to give you the same answer as 2 times 3. Notice that those numbers, they kind of switched positions, but you're still getting the same answer. And that's what the commutative property is. Here's the definition. Commutative property for addition and multiplication. The property by which changing the order of the numbers does not change the sum, which is the answer to an addition problem, or the product, that's the answer to a multiplication problem. So let's do that for you if you're a visual learner. So that A plus B is equal to B plus A. Well, in our example, A was 2 plus and B was 4, right? And B plus A would just look like that if you needed a model there. And in multiplication, 2 times 4 would be equal to 4 times 2. The order of the numbers have been switched, but you still get the same answer. There's just another visual model there for you at home. An example for addition. And then there's an example for multiplication, and we'll be focusing more on the multiplication aspect of this property. So let's try another one. Let's do 3 times 5. And you might already know the answer to this. I hope you do. 3 times 5. So I'm going to get 3. And now I need to do that 5 times. So there's 2 columns. There's 3. Let's do 4 and 5. So now I have a visual model of 3 times 5. So I have 3 over here, and I have 5 columns, 3 rows and 5 columns. So what's inside this whole thing? There's 1, 2, 3, 4, 5, 6. You probably can't see that, can you? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the answer is 15. One thing you could do is think of these in groups. There's 1 group of 3, 2 groups of 3, 3 groups of 3, 4 groups of 3, 5 groups of 3, right? So I'd have 5 groups of 3 tiles. You could say that's 5 times 3 is equal to 15. Or you could totally think of the numbers in different order. You should get the same answer, right? So I'm just going to leave the circles up there and think of it in a different way. I'm going to think of that I have 3 groups of 5, which is thinking this way. So now I have 3 groups of 5 tiles. Mathematically, that would be 3 times 5 is equal to 15. Notice the order of the numbers have been switched, but you still get the same answer. And that is true of addition or multiplication. I hope this has been helpful to you. I have a feeling, though, that you are familiar with this. You just might not know the fancy word for this property, which is the commutative property, which is right there. And it works for addition and multiplication.